Hi, great pals. Let's do a few derivatives using our rules. Now, which rules am I talking about? It's the rules that say that we're not allowed to work with a bracket, we're not allowed to have any fractions, and we don't want to work with any surds. So we need to get rid of our brackets, our fractions, and our surds before we can do the short method of using our derivative. What is the short method? It's when we have a variable with an exponent. You take the exponent at the top, times it to the front, and minus 1. But we'll look at that when we do these examples. So let's have a look at the first one. So it says determine the derivative of y in terms of x, dy over dx. That's what that means, the derivative of y in terms of x. If y is equals to the bracket of x minus 2 squared. So when we want to do the derivative, we first need to simplify our y is equals to equation. When simplifying the y is equals to equation, we first need to get rid of any brackets, fractions, or surds. In the first example, we are working with a bracket. So the first thing is we need to get rid of this bracket. And if I have a bracket with two terms that are squared, I need to simplify it. Now you can either write it out twice, or you can do your short method, where you take the first term and you square it. You take the first term, times by the second term, and times it by 2. And lastly, you square your second term. So you need to take the whole second term with a sign and square it. So it's always going to be a positive here at the end. All right, so now I have simplified my equation for y. Y equals cannot be simplified any further. So that means I can finally continue to my derivative of y in terms of x. So now the short method says, take the exponent that you have on top and multiply to the front. Now remember, there's an invisible 1 here. So 1 times by 2 gives us 2. Then we rewrite the x. Now you take the exponent that you had on top, obviously, because it's an exponent, and you subtract 1. So 2 minus 1 only gives us 1 here. I'm not going to write the 1, but just so that you can see, we have 1 there. Now I can go to my next term. Negative 4x to the power of 1. There's an invisible 1 on top. 1 times by negative 4 gives us negative 4. Now if I subtract 1 from this exponent, 1 minus 1 is 0, and anything to the power of 0 gives us 1. But it's not necessary to write the 1 over there. So when we do a derivative of only x, we only rewrite the coefficient. The x is going to fall away. And then the derivative of a constant is equals to 0. That's a very important rule to remember. The derivative of a constant value is always equals to 0. And there we go. We have now calculated the derivative of y in terms of x. Let's go to our second example. Our second example is where they say f of x is equals to 2x squared plus the square root of x to the power of 5 divided by 6x. And now it's important that we go back to our grade 8 and 9 mathematics, which says that if I have more than one term in the numerator, but only one term in the denominator, that we can actually split it up and write each of them on top of the denominator by themselves. So, as you can see, I'm continuing with f of x. I'm simplifying my f of x equation. I'm not yet doing the derivative. So I continue with f of x only. So this is now 2x squared divided by 6x plus. Let's quickly simplify the surd, because remember we want to get rid of any fractions, we want to get rid of any surds, and we want to get rid of any brackets. This question doesn't have brackets. We addressed that at the top question. Now we are getting rid of the fractions and our surds. Now remember, we have a rule that says if it's not inside, it's on top. So we are going to put that 5 on top of the invisible 2 that we have here with our root. And then we divide by 6x. So this changes to x to the power 5 over 2. And I've taken my fraction and I've split it up so that each one is on their own denominator. Now we can simplify. 2 divided by 6 gives us a third. x is the largest on top, which means we take this 1 that we have to the top and we subtract 1. And this is then x to the power of 1 only. I'm not going to write it on top with the 1 so that I have x over 3 because we want a coefficient. Because of our short rule that says we take the exponent at the top, times it to the front, and minus 1. So now we can continue to our next fraction where we have, there's an invisible 1 here again. So 1 over 6, so plus 1 over 6. Now, once again, the exponent is 1, take it to the top, minus 1. And we can say this is x to the power of 5 over 2, minus 1 gives us 3 over 2. And that is still f of x. We have still only simplified this equation. Now we have gotten rid of any fractions that we have with an x in it. So we don't have x in a fraction anymore. Yes, we have a third, but that's just the coefficient of x. We have gotten rid of our surds, and we don't have any fractions to worry about. So we can now go to our first derivative. And our first derivative is now take the 1 at the top, times it to the front, minus 1. Once again, if I am going to do the derivative with an x, the x is just going to fall away. So I have a third, plus take the exponent, times it to the front. 1 over 6 times by 3 over 2 gives us 1 over 4. And then we say minus 1 at the exponent. 3 over 2 is 1.5. Minus 1 gives us only a half. And there we go. We have found the derivative.